Engineering is the backbone of human progress. It has given us towering skyscrapers, high-speed railways, and missions to space. But what happens when things go wrong? When ambition surpasses caution and errors, whether human, mechanical, or environmental, turn dreams into nightmares. Today, we explore some of history's biggest engineering disasters, catastrophic failures that not only cost millions but also changed the way we build, innovate, and understand the limits of technology and nature. The Tacoma Narrows Bridge collapse, November 7, 1940. The Tacoma Narrows Bridge, an architectural feat spanning the Puget Sound in Washington, was an engineering marvel of its time. Designed with an elegant, narrow structure, the bridge was meant to be a shining example of modern suspension bridge technology. But something was deeply flawed in its construction. Engineers had overlooked one crucial factor: aerodynamics. As the wind funneled through the Narrows, the bridge began to sway, oscillating back and forth in what initially seemed like a minor vibration. However, as wind speeds increased to just 40 miles per hour, the oscillation intensified dramatically. The entire structure twisted violently, creating a rolling motion known as aeroelastic flutter. This unanticipated aerodynamic phenomenon exerted extreme forces on the bridge's cables and deck, eventually leading to its catastrophic collapse. The disaster was a wake-up call for civil engineers worldwide. The failure of the Tacoma Narrows Bridge forced a complete re-evaluation of how wind forces interact with suspension structures. Future bridge designs incorporated wind tunnel testing, aerodynamically stable shapes, and dampening mechanisms to prevent similar disasters. What was once an oversight became a lesson that helped shape modern engineering standards for bridges worldwide. The Chernobyl disaster, April 26, 1986. The Chernobyl nuclear power plant in Soviet Ukraine was undergoing a routine safety test, one that would inadvertently trigger the most devastating nuclear disaster in history. Reactor 4, the one being tested that night, had a fundamental design flaw: a dangerously unstable graphite-moderated reactor that became increasingly reactive at low power. Combined with poorly trained operators and ignored safety protocols, a chain of irreversible failures unfolded. As engineers attempted an emergency shutdown, a critical flaw in the reactor's control rods caused an explosive power surge. Within seconds, Reactor 4 exploded, releasing an immense amount of radioactive material into the atmosphere. Flames engulfed the structure as firefighters, unaware of the extreme radiation exposure, rushed to the scene. Within hours, the town of Pripyat, home to tens of thousands, was on the brink of evacuation. The aftermath of the explosion was harrowing. The radioactive fallout spread across Europe, leading to long-term health crises, forced evacuations, and a widespread re-evaluation of nuclear safety worldwide. To contain the ongoing radiation, the Soviet Union hastily constructed a concrete sarcophagus over the reactor. Decades later, a massive steel structure was placed over the remains, yet the area remains highly contaminated. The Chernobyl disaster underscored the dangers of cutting corners in high-stakes engineering. It highlighted the necessity of stringent safety protocols, proper training, and transparent reporting. The lessons learned from Chernobyl influenced nuclear energy policies across the world, ensuring stricter regulations, improved reactor designs, and greater accountability in handling nuclear power. Engineering failures are not just tragedies, they are lessons. Each disaster, from the collapse of a bridge to the space shuttle, has led to safer designs, better communication, and stronger safety measures. While progress often comes with risk, history has shown us that innovation must always be accompanied by caution and responsibility. The Tacoma Narrows Bridge collapse taught us the importance of understanding aerodynamics in large structures. The Chernobyl disaster highlighted the devastating consequences of poor design, mismanagement, and secrecy. By learning from these disasters, we continue to push the boundaries of human achievement, safely and responsibly. Engineering is a powerful force that shapes our world, and when done right, it allows us to reach heights once thought impossible. But when mistakes are made, they serve as harsh reminders of the responsibility that comes with innovation. The past holds the key to the future, and by studying these failures, we ensure that the next great leap in engineering is built on a foundation of knowledge, safety, and wisdom.